this question. I said this is one of the laws of sort. I've given you laws of indices, logarithm. Now this is sort now. So this is one of the laws of sort. It's also very important to note that if you have square root of x over y, it's the same thing as square root of x divided by, or rather let me put it the other way around. If we have root x divided by root y is same as this. So these are laws of sorts. We're going to apply these laws in solving this question. We're applying these laws in solving this question. So we have 1 times 1 in root 3 is root 3. We have to multiply this is root 27 times root 3 plus root 3 in root 3 is 1 times 3 is 3. So this, from this first law that I give you, would be root 27 times 3 plus 3 over root 3. 27 times 3 is 81. So the square root of 81 plus 3 over root 3. And the square root of 81, we know that to be 9. So 9 plus 3 over root 3. Yeah, 9 plus 3 is 12 over root 3. Now, most times, you do not leave your answer in sorts. You don't leave the denominator in sort most times. It's advisable you multiply both numerator and denominator by that sort at the denominator. So if we multiply, we get 12 times root 3 is 12 root 3 over root 3 times root 3. I taught you that. We've answered about 3 questions on that. So you know this would give us 3. So 3 would go into 12 4 times, leaving us with 4 root 3 as the answer to that question. So that is option A. Option A. Now, we'll go to the next question. Oh, interestingly. Okay, we have one more question, which I'll leave you to solve that question. So that would be like a homework. When I'm done with my algebra, I will bring the answer to that question. So you see if you have done very well or you have not done well there. We'll solve similar questions. Yeah, so you know the laws. When you find something like this has to be a minus. So log 72, let me just give you the clues. This is 2 log 2 over 5. This will give you, remember the 2 over here comes back here, and you have square. 2 over 5 raised to power 2. And then here, this is 72 over 125. That's simply log 72 minus log 125 and plus log 9. So that is that. Let's just solve that question. Let's solve the question. Because it looks, that's actually a more complex question. More complex than what I solved earlier. So we have 2 log 2 over 5 minus log 72 over 125 plus log 9. Now take note. Now we have not had, or we do not have, the base. No base is given. So when no base is given, what it simply means is that it's the same base. Base 10 most times. Now we have this. So this will give me log 2 over 5 raised to power 2. One of the laws of logarithm I gave you. Log 2 over 5 raised to power 2 minus log 72. Look at this. Minus log 125. Look at that. Very important. And then we have plus log 9. Hello? I hope you can see this. And then we have that. Now, so look at this. I'll decide to put it this way. Can you see this? I try to use brackets. So if I open the bracket, I have log 4a. What you have outside the bracket affects everything inside the bracket. More like if you have 2 into x plus 5. The 2 multiplies everything. So when I have 2 over 5 squared, the square applies to both. So this is 2 squared and this is 5 squared. So that's the same thing. So we can have 2 squared is 4 and then 5 squared is 25 minus log 72 minus log 125 plus log 9. We see that? Now, if we explain, this will give me log 4 minus log 25. What are we doing? We're simply applying the laws of logarithm to solve this question. So we have log 4 minus log 25 minus, look at this, log 72 plus log 125. And then I have plus log 9. Let me put that here. Okay, now what did you observe? This sign has changed to plus. Why did it change? Because the minus here has affected it. So we can deal with that. From our laws of logarithm, bring all the plus, or you can deal with all the plus, and then you have the minus here. So this is log 4 times, can you see this? Log 4 times 125 times 9 all over 25 times 72. Someone is wondering what Mr. McCollins has done there. Well, I told you one of the laws of logarithm, log x over y base a is simply log x base a minus log y to base a. So I have dealt with this minus. Can you see this? So that's what we've done. Are we okay with that? Now it's simple. So we can work on that. Now we can find 5 25s in 125. 9 can go into 72 8 times. 4 can go into 8 2 times. So now that leaves me with log 5 times 1 is 5. So 5 over 2. Log 5 over 2. Now log 5 over 2 is simply log 5 minus log 2. Log 5 minus log 2. Now, but what is log 5? Remember I told you, of course you know that 5 is simply 10 over 2. I'm sure you know that. So we can apply that here. So that will give me, okay, I need to come up here. If I take what we have down there up here, at any point you can pause the video and rewind if you've missed that part that I erased. I have log 10 over 2 minus log 2. So this is log 10 from the law of logarithm minus log 2 minus log 2. So log 10 to base 10, one of the laws of logarithm I taught you, I think the last one I gave, is 1. I told you all the logs are in base 10. So this is 1. How many log 2 do we have here? We have 2 log 2. So that will be 1 minus 2 log 2. Let's see if we have the answer there. 1 minus 2 log 2. The correct answer is option D. I want to believe you are enjoying the class. Do not forget, mathematics is not read. You don't read mathematics. You study mathematics. And you know mathematics by solving mathematics. So for all of these things I've taught you so far, I'll advise you write out the questions somewhere, go over the videos, and try on your own to solve those questions yourself and see if you can get the same answers that we got in the course of the teaching. Now that brings me to the end of numbers and numeration. I have some questions in the next part, which is algebra. Well, I tell my students that algebra is a marriage between numbers and letters. When you see numbers and letters together, that's simply algebra. Now what we did earlier was just numbers. You can see this. There's no letter here apart from the log. Log is not, letter is a sign. So 2, 10 over 2 and all that. So now we want to go into algebra. Now under algebra, we have some topics. So like I said, I'm not going to take time to teach you the different topics. I'll teach you by solving the questions. Let me take you back to what we have, the topics we have under algebra. Now, if you look at this, we have polynomials, variation, inequalities, progressions, binary operations, and matrices and determinants. So I'm going to be solving questions from those simple topics. I tell you, those topics are very, very simple topics. They are things you did in your year 10, as far back as your 10. Now here we have this question of this topic is inequalities. Find all real numbers x which satisfy the inequality. So I asked my student one of those days, I said, so what's the opposite of real numbers? And he said fake numbers. Well, I don't know if there are fake numbers in mathematics, but well, find all real numbers. That's numbers that are on your number line. Those are the real numbers which satisfy the inequality. Now let me tell you something, these inequalities. Now it's important to note the difference between inequalities and your normal equation. Now inequalities differ from your normal equation in different ways. Number one, the sign. Your equation carries the equal sign, but your inequalities carry their signs. You have what you call the greater than sign, the less than sign, the greater than or equal to sign, less than or equal to sign, and we have not equal to sign, and so on. Now, well, I don't know, in this part of the world, we have a bias, for right hand. So we say this is greater than, so we say the right hand is greater than. But I don't know who came about that then. So if it looks like this, like the right hand, as you can see this, look at my right hand. So this is greater than. So this is less than. So because we favor the right over the left, no prejudice, without prejudice to those who use left hand base. Forgive me. So this is greater than, this is less than, it's greater than equal to, less than equal to. But there is no equal to sign here. That's one difference. Number two difference is this. Now for your equal sign, sorry, your equation, you have definite values. The answer to this equation is this. But for your inequalities, you don't have definite value. What you have is a range of numbers. Let me explain that. If you have 2x plus 5 equals to 7. Find x. Finding x, 5 comes over here. We have 2x equals to 7 minus 5. 2x equals to 2. If we divide both sides by 2, x is 1. X is 1. There is no other answer. X is 1. But if this was an inequality sign, let's say greater than. Now, if I try to solve this question, the equal sign changes. If we divide 2 by 2, we have 1. Now, I was telling you the difference between an equation and an inequality. Now, when we solved this question earlier, when we had equal sign here, we had 1 for the answer. But now we have inequality. We've changed the equal sign to greater than. Now what we have is x is greater than 1. What this means is that all the numbers that are greater than 1 satisfy this inequality. You see the difference? I've told you. First difference I gave you, I told you that when you have inequality sign, it's quite different from the equal sign, because now the difference is in the signs, number one. The second difference is for your equal to, or your equation rather, what you have is an exact value, just one answer. For inequalities, you have a range of numbers. So this, you cannot say that the answer to this question is 1. No. The answer to this question is every number that is greater than 1. So whatever you can think of, 1, 2, 4, 1,000, 1 million, will satisfy this inequality. So let's quickly solve the question as we make progress. So what do we have there? We have find all real numbers x which satisfy the inequalities. 1 over 3 x plus 1 minus 1 greater than 1 over 5 x plus 4. And let's go. Now look at this. You solve inequalities the same way you solve the normal equation. The difference is just the sign. So we have, this is the same thing as x plus 1 over 3. Take note of that, please. 1 over 3 times this is the same thing as x plus 1 over 3. Minus 1 is greater than x plus 4 over 5. Now this is 1 here, so I'm going to make it over 1 so we can have a fraction. So how do we deal with fractions? LCM of 3 and 1 is 3. 3 and 3 is 1. 1 times x plus 1 is everything there. 1 times 1 and 3 is 3. 3 times 1 is 3. Take a look at that. We have the sign, don't forget the sign. Greater than x plus 4 over 5. This can be simplified. This is plus 1 minus 3. You owe 3, you have 1. When you make your payment, you have, you still owe, right? You owe 2. So x minus 2 over 3 greater than x plus 4 over 5. Now we can cross multiply. I told you the condition. When you have two fractions on either side of the equal sign, but here we don't have equal sign, we have the inequality sign. So we have two fractions. So what do? We cross multiply. When we cross multiply, this is what we have. 5x minus 2 is greater than 3 into x plus 4. Can we see that? Now, this is what we have. This cross multiplies. This comes here, this comes here. Now, please take note of this. When you are cross multiplying, because many students make this mistake, in your normal equation, look at it this way. If I have x over 5 equals to 2 over 3, when you are not cross multiplying, some students make this mistake. They do 2 times 5, 10 equals to x times 3, 3x. For your normal equation, you get the same answer, but not for your inequality. Please take note of that. The right way to cross multiply is this. 5 goes to 2. 3 goes to x. So it should be 3x equals to 10. Now, I'll tell you, because you may not have a problem when you're doing your normal equation, but you will definitely have a problem when you're doing your inequalities. If you cross multiply the wrong way, please take note of that. So, do not forget, it is not this goes down here. It is this goes up here. The denominator goes to the numerator. Please take note of that. You see what I did? 5 has gone here, and 3 has gone here. I didn't do x minus 4 came down to make 3. No. The right way to do cross multiplication is 3 goes here and 5 goes here. Take note of that, please. Now let's solve that. Open the brackets. We have 5x minus 10 is greater than 3x plus 12. So collect like terms. 5x minus 3x is greater than 12 plus 10. So 2x is greater than 22. If I divide both sides by 2, it will give me x is greater than 11. You have the answer there? Yes. Option D. X is greater than 11. That's the correct answer. Okay. Now this is very interesting. Binary operations. Now I'm going to give you more binary operations questions. Okay? So I will not teach you the topic afresh, but I'll teach you as I solve the questions. Now we have binary operation. Binary operation. Now binary operation is a very simple part of algebra. I'll explain how that works. To solve the question, a binary operation X, it says, is defined by A star B. This is actually an operator because it's an operator. So it can be anything. It can be, you can see any sign. Okay, any symbol, any sign. So A star B equals to A raised to power B. Now, what this means is this is a law. Okay, this is a law that shows you how to treat when you have a combination of terms. It can be numbers, it can be letters. This is what happens to them. This A star B, every time you find A star B, it should always be A raised to the power B. If A star 2 equals to 2 minus A, find the possible values of A. Let me quickly explain this. Look at that. A operator B equals to A raised to power B. Do you know what that means? If you have a question that says, find 2 operator 5. Do you know what's this? Very simple. It's simple. This is the law. For every time you see A star B, it will be A and then the B becomes the power. So 2 operator 5 will be what? Good. Your guess is as good as mine. 2 raised to the power of 5, which is 32. You see that? It's very simple. So it's the law. This is the rule. the rule. For every time you see this, this is what you do to that. Now, the question says, if a star 2 is 2 minus a, find the possible values of a. Now, what do you think a star 2 will give us if we follow the law? A raised to the power of 2. Now, but the question says a star 2 is also 2 minus a. So if a star 2 is a raised to the power of 2 and a star 2 is 2 minus a, now what that means is that a squared will be the same thing as 2 minus a. Is this making any sense? This is looking very much like a quadratic equation. It's actually a quadratic equation. So let's solve this. So we have a squared. We can bring the a in here, plus a minus 2 equals to 0. This is factorizable. We can factorize it. Now, I taught you how to do that earlier. Bring these two together. We have the minus 2a, when you multiply this, 2a squared. Split this open. We have a, because it's a squared, we have a. Find two factors of 2 that would give me 1. 2 and 1 will always give me 1, right? 2 factors of 2. So 2, but take a look, the sign here is positive. The sign here is negative. So the bigger number takes the positive. Please note this. Whenever you have minus here, whatever you have here, if it is minus, it means the bigger number takes the minus. If it is plus, the bigger number takes the plus, the bigger factor. So this is 2 and this is 1. So we have 2 here, 2 takes the positive. 1, well, we're big boys. We don't use 1a, we just say a. Okay? So a takes the minus. So when we come back from our short break, we'll solve this question and then we'll find the answer.